So here we are, part 2 of solving inequalities. Yesterday, we watched a video on how we write and graph. Today, we're going to get into how do we solve an inequality to get to that point of graphing. Well, here would be an example of an inequality. 2x plus 5 is greater than 7. We're going to solve them and use the same exact rules we used last week with solving equations. So if you take a look, our problem on the left, that is an inequality. Our problem on the right is an equation. The difference between the two is our equal sign or our inequality symbol. So our same rules of isolating the variable apply. So if I were to solve the equation on the right, I'd subtract 5 from both sides. Well, I do the same thing with my inequality. Nothing changes. I would, on my right equation, get 2x equals 2. With my inequality, it's just 2x is greater than 2. It's still the same process. So now to isolate my x, to get x by itself, I would divide both sides by 2. And in this case, I get x equals 1. But over here, when I divide both sides by 2, I still get 1, but its x is greater than 1. So that's going to look different when we go to graph. So it's still a number line. We still have our number 1. With our equation, we'd plot just the point. X is 1. That is our only answer. But with the inequality, we'd have an open circle at 1, and we'd have to shade everything to the right because anything greater than 1 is a possible solution. Remember, our circle on the 1 is open because it's greater than 1, not equal to 1. So let's go and look what happens because there is a specific rule that you learned last year. When we multiply and divide an inequality by a negative, something happens. We need to switch the direction of the symbol. Please pause and write that down now. When multiplying or dividing by a negative, we switch the direction. So let's see what that looks like. So let's look first at this negative 2x is less than 4. Notice the negative right here is with the 2, okay? I am dividing by a negative on both sides. So in this case, I switch my inequality symbol. Do you notice it is now facing a different direction? It now says x is greater than negative 2. Well, when you look on this other example, it almost looks like the same exact problem, but look where the negative is. The negative is over with my constant. So in this one, I'm dividing by a positive 2. So in reality, I don't switch my symbol. The negative was not what was happening on both sides. Does everyone see the kind of the difference here? Let's go look at it again when we have to go with multiplying. So on this first one, okay, I have that I am multiplying by a negative 3 on both sides. No, what I am doing to both sides is negative. That's when I switch my symbol. But if you look at the next example, okay, you notice what's happening on both sides. At this first one, that's what switched it. But on this one, both sides is a positive. So I'm not going to switch my symbol. It's going to stay. Do you see how I have circled those negatives there and I switched the symbol? Okay. This symbol on this one stayed put, and that's because I multiplied by a positive. Okay, so right now, we're going to find the solution set to each inequality. And then we're going to express the solution in set notation and graph. Again, we're using the same rules as solving an equation. So what am I going to do first in this first problem? I'm going to bring my variables to the same side. So I'd be left with m plus 2 is less than negative 4. Same rules. Step 1 is distribute. There was nothing to distribute. Step 2, combine like terms on each side. There is nothing to combine. Then that brought me to step 3, where I bring the variables to the same side. Step 4, I need to bring my constants to the opposite side. So in this one, I'm going to subtract 2. Notice what I just said, ladies and gentlemen. I said subtract, okay? What that means is my symbol stays the same direction. Just because you see a negative there doesn't mean it switches. So my final answer is m is less than negative 6. So if I were to graph this, I would put negative 6. It's a less than, so it's an open circle, okay? And it's going to shade to the left. There is my graph. This is something new. This is called set notation. It's basically saying m such that m is less than negative 6. That's it. That's set notation. You're stating the variable, and you're stating the variable's possible solutions. Anything less than negative 6. Okay? So let's go try this next one. That a divided by 5 cannot be touched until I bring my constants together. So I do that by subtracting 8 from both sides. That leaves me with a divided by 5 is less than or equal to 5. Okay? Now, what operation's happening between the a and the 5? Right, I'm dividing. So to undo division, I have to multiply both sides by 5. Once I do that, I'm left with just a. My symbol doesn't change. And then 5 times 5 is 25. So how do I graph it? I draw my number line and I write 25. Whatever the number was you got. It's going to be a closed circle on 25. If you look at the direction the arrow's pointing, it's pointing to the left, so I shade to the left. Set notation, okay? A such that a is less than or equal to 25. So now I want you to look at this one. We have now step 1, we have to distribute. So you'll see an arrow here. My advice to you is to actually draw this arrow. If you want to try this problem before I go over it with you, pause it. Do your work and come back and see if you're right. So if I distribute this negative 3 to the x, I get negative 3x. Okay, then I have to do negative 3 times negative 7 is a positive 21. Then I bring down whatever I didn't touch. Now I'm at a two-step equation that we did last week on Monday. I work to isolate x by bringing 21 over. I bring it over to the other side through its inverse operation. That is the only way I can bring it over. So I'm left with negative 3x is greater than negative 48. I haven't isolated my x because it has a negative 3 with it. So if I divide both sides by negative 3, I have to do something. Yes, I'm left with x here, okay, and a positive 16 here, but what is it that I have to do? I hope you all said, switch your symbol. Notice I am dividing by a -3 on both sides. Excuse me. So my inequality symbol switched. If I graph, okay, I put my number line, I put a positive 16. It's going to be an open circle, and I'm going to shade to the left. My set notation is x such that x is less than 16. Okay, meaning any number that is less than 16, you could plug into this inequality and the statement would be true. Okay, so notice what happened. Notice how these -3's got bigger. I need you to see where it is. Where in your steps does it tell you to switch the direction of your symbol? It's because both of those numbers being divided are negative. That might be something I would circle on my notes. Circle those -3 and write a little arrow saying dividing by a -3. Okay? Okay, so let's go look at my next one. Step 1, anytime I solve an equation is to distribute. This time I've got to distribute twice. So I have to do 8 times p to get 8p. And 8 times -6 to get -48. Just leave it at -48. On this side, I have to do 4 times p and 4 times -4 to give me -16. Okay? So now I've distributed. Step 2 is to combine like terms on each side separately. So if I take a look here, that's already done. My left side, the terms are combined, and my right side. So I'm now going to step 3, where I bring my variable terms to the same side. And this is why Mrs. Nell and I say, bring your variables together first and bring them to the left. What happens is, I have 4p minus 48 is greater than -16. This allows me then to bring my constants to the opposite side by adding 48. Finally, I have 4p is greater than 32. So if I divide both sides by 4, okay, I'd get p is greater than 8. Everyone with me? So we draw my number line. I place the number 8 right in the center. It's going to be an open circle, and it's going to shade to the right this time. My set notation is p such that p is greater than 8. You have to know how to write that. It's very important. There is another notation called interval notation, and we will get to that this year. So here's kind of the peak of everything where it starts getting a little bit more challenging. We have a word problem, okay? Miss Ake is paid $12.50 per week, but is fined $100 each day. She is late to work. Miss Ake wants to make at least $3,000 over the next 3 weeks so she can take a vacation. Over the next 3 weeks, what is the maximum number of days she can be late to work and still reach her goal of making at least $3,000? So you got to look at this. What's our key facts here? Okay, we're looking at the number of days. We're trying to figure out how many days she can be late to work for whatever reason she's late sometimes, okay? So that's our variable. That's what we don't know. That's what we're searching for. We know that she makes $12.50 per week, right? She's fined $100 Find. That's a key word. Underline that one. Okay? And she has to make at least $3,000 over the next 3 weeks. So there's a lot of information there that we got. So let's think about it. How much is she going to make over the next 3 weeks? Think about how we could find that out. She wants to make at least $3,000. You know what she's going to be guaranteed to make over 3 weeks' time. Okay? So 3 weeks is kind of our magic number. And we're trying to find the biggest number of days that she could be late without going over. So let's see what we would do here. How much will she make over 3 weeks? Write that down. What do you think? Remember, you're using a pencil so you can erase it. Well, it was $1,250 over 3 weeks. So we would do 1,250 times 3. So we know her income is going to be $3,750, right? What else do we know? Do we know the number of days she's going to be late? No, we don't. Okay, that's our D. And we know that every day she's late, she's going to lose $100. Okay. We know that we want to at least make $3,000. So at least, meaning what we have here can be bigger, but it has to be at least equal to the $3,000. So now my question is, what are we doing with these numbers here? We have 3,750 minus 100D. Why did I subtract? Well, that's why I underlined the word find. When you're find, you're losing that amount of money. And we know that it has to be greater than or equal to 3,000. Because remember, if we wrote our symbol the other way, she might make less, and then she's not going to be able to go on vacation. So when we solve this, pause now and solve it on your own. Okay. We'd isolate our variable by subtracting 3,750. So that leaves us with 100D. But notice what I have written here. It's negative 100D because that was a minus. Now, some of you might be saying, there's 2 negatives. How do I have a negative amount of money? Well, when you go, or amount of days, I'm sorry. When you divide by negative, a negative divided by a negative ends up with a positive. So my question is, she can be late to work. The number of days can be less than or equal to 7.5. But my question was, what is the maximum number of days that she can be late without going below 3,000? Maximum number. So would I round this up or would I round this down? I would round it down. Because if you go to day 8, you've lost another 100, you're under 3,000. You've got to be below. So there's some real world problems where we would round down, and then there's some where we would round up. So most of our brains are saying, oh, 0.5, round up. But if you go to day 8, she's now below $3,000. Okay? So this is a challenge, and I want you to just attempt to come up with the problem on your own. And then we'll go from there. Okay, let's see what we have. We know that Brady's test score must average, okay? Must be an average. Well, what is an average? An average is when I add all the numbers there are and divide by how many there are, right? So if there's 5 numbers, I add all 5 and I divide by 5. We know on his first 5 tests, his average, okay, was a 77. But do I know the total of all 5? Well, we can let S equal the score on the 6th one, okay? And then we can go through and find what he got on test 5. How do I do that? Well, they gave us some information. We don't know the total on his first 5 tests, okay? But if I take the total and divide by 5, what did that give me? What was his average? It was 77, okay? So if I work backwards, I know that his first 5 tests were 385, okay? So we know the total of the 5 tests he already took now. Before we didn't. But working backwards, I found out that the total of the 5 tests he took was 385. Well, if S equals the score of the 6th test, think about what we would need to do now. Does this change your setup maybe? So remember, average means to add all the numbers and divide by how many there were. Well, his first 5 tests, and he's got 1 remaining. So his first 5 were 385. He's got 1 remaining. So if I add all those together, how many tests were there? 6 tests. So we had a total of 6, meaning I eventually am going to divide by 6. What do I know that has to equal? Okay. It says a minimum score. So is it going to be an equal sign? We want a minimum of 80%. So can this score here, the 385 plus S divided by 6, can that be bigger than 80? Yes, it can. Okay, so this together, whatever we do when we do this calculation, it can be bigger than 80 or it can equal 80. Okay, so that's why we use this symbol when we say a minimum, meaning we want it to at least be 80, but it could be more. So now I'm at the point, all I have to do is solve. I would isolate by multiplying both sides by 6. Okay, and that would give me 480. Then I subtract 385 to get 95. And guys, this is something you could do. You could try and figure out what score you need to get on a test so that you average a certain score in a class. Every teacher's grade book's different, so you might have to calculate a little different, okay? But it is doable. So if he wants to pull a B in the course, he needs to really do well on this last test because he's blown off the other 5. So he has to get a 95 or above. So if he gets a 94, he's not going to finish the course with an 80. Okay? That's what this is telling us. So he now knows his minimum score. There was a lot that got thrown at you today, so there should be something in the summary. Was it a word problem? Was it the setup of a word problem? Be specific. If you understood it, summarize the key fact that you can take away from this lesson.